1,
2,
3, 4.
Thank you. All right. Hi, I'm Drew Coleman, and this is how airplanes generate lift and are able to stay in the air. Imagine waiting in your gate in an airport and watching a commercial airplane weighing hundreds of thousands of pounds speed down the runway before lifting gracefully like a bird into the sky. It seems completely impossible that something so large and so big is able to leave the ground and stay in the air for multiple hours at a time. Yet every day, tens of thousands of airplanes safely transport millions of passengers around the world. As someone who has quite recently gotten interested in aviation, I've still often wondered exactly how airplanes are able to fly, even when I was younger. While it may seem like dark magic, the answer is actually quite simple. It all comes down to the laws of physics and the insane capability of modern engineering. According to the Federal Aviation Administration, or the FAA, the ability of an airplane to fly depends on balancing the four basic forces and generating enough lift to overcome the power of gravity. Today, I will explain how airplanes are able to generate enough lift and stay in the air by discussing the four basic forces of flight, how airplane wings create enough lift in themselves, and how pilots maintain safe and controlled flight throughout a trip. Before we can understand the process of the liftoff, we must first understand the four forces acting on every airplane. The first force is, funny enough, called lift, which is the upward force produced by the wings of the aircraft. Lift is what allows an airplane to initially leave the ground and remain airborne throughout a flight. The second force is weight, which is simply the force of gravity pulling the airplane back towards the earth. Every single aircraft, regardless of whether it is big or small, is constantly affected by gravity in the air. The third force is thrust. Thrust is produced by the massive engines of the aircraft. Whether powered by propellers or even a jet engine, thrust pushes the airplane forward through the air, counterattacking the force of gravity. The final force is called drag. Drag is the amount of air resistance that acts against the airplane's forward motion. You can think of the drag kind of at the same resistance that you feel when you stick your hand out of a moving car window. According to the FAA's Pilot Handbook of Aeronautical Knowledge, an airplane successfully flies when the lift is greater than the weight and thrust is sufficient enough to overcome the drag. During steady, level flight, all these forces combine and balance out, allowing the aircraft to cruise ever so smoothly throughout the sky. Understanding the basics of these four forces provide the foundation for understanding how flight is possible. Now that we discussed the four forces of successful flight, let's look more closely at how the wings are actually able to create a lift. Airplane wings are perfectly engineered with a special shape called an airfoil. Instead of being completely flat, the upper surface of the wing is curved up, while the lower surface is only somewhat flat. This type of design helps direct the airflow around the wing. According to NASA's Glenn Research Center, as air in the atmosphere flows around the wing, the shape of the airfoil and the angle of the wing cause changes in both air pressure and airflow. This actually ends up resulting in the upward force that we call lift. This is also why you will see the wings of a plane move up and down during a flight. The strong flexibility of the wings help direct the air where it needs to go at a high speed. The wings aren't going to fall off like a lot of people think. They are perfectly engineered to move exactly the way that they do. One explanation comes from Bernoulli's principle, which shares that faster moving air creates lower pressure. Because air generally moves faster over the curved top of the wing than beneath it, pressure above the wing becomes lower than the pressure underneath. This difference in pressure is what leads to a beast of a plane being able to lift up in the sky. However, NASA also explains that Bernoulli's principle is only a very small part of the story. Another important explanation comes from Newton's third law of motion, which states that for every action, there is an equal and opposite reaction. As the wing moves through the air, it pushes air downward. In return, the air pushes upward on the wing, helping create the lift. An easy way to picture this is to go back to what I said earlier about drag. Imagine you stick your hand out of the window of a moving car. If you tilt your hand slightly upward, you will immediately feel the air push upward on your hand. And vice versa, if you tilt your hand downward, you feel the wind move downward on your hand as well. An airplane wing works on a very similar principle, although it is much more structurally engineered to deal with the feedback of the air. So instead of relying on one single scientific law, airplanes generate lift because of the combination of the wing shape, the movement of the air, and Newton's third law of motion. Creating lift is only the beginning though. Pilots must constantly manage the airplane to maintain safe flight. One of the most important factors is the airspeed. If an airplane slows down too much, the wings are unable to generate enough lift, increasing the risk of a stall in the middle of the air. On the other hand, maintaining the proper speed allows the airplane to continue producing the lift that is needed to stay airborne throughout the whole entire flight. Pilots also control the airplane's angle of attack, which is the angle between the wing and the oncoming airflow in the atmosphere. According to the FAA, increasing the angle of attack generally increases lift, but only up to a certain point. If the angle of attack becomes too steep, airflow separates from the wing, lift decreases rapidly, and the aircraft can stall in the middle of the air. In addition to speed and angle of attack, pilots use several control surfaces. The ailerons, located on the wings, control the roll of the plane and allow the plane to turn in the middle of the air. The elevators, which are located on the tail, control pitch, allowing the nose to move up or down during climbs and descents. The rudder, mounted on the vertical tail, controls the yaw, helping keep the airplane coordinated during turns. Finally, pilots are constantly adjusting engine power to increase or decrease thrust depending on which phase of flight they are in. During takeoff, engines produce maximum thrust to accelerate the plane enough to lift off. During cruise and flight, thrust is reduced to maintain an efficient speed while balancing drag. This is why you sometimes hear a roaring sound right after takeoff. Pilots are slowing the thrust down to test the engine and also balance out the plane at the same time. All of these adjustments happen continuously throughout every single flight, often without passengers ever noticing a thing. In conclusion, airplanes stay in the air because of science, modern engineering, and skilled pilots, not because of magic. Today we learned about the 4 forces of flight, how specially designed wings generate lift using principles explained by both NASA and the FAA, and how pilots constantly adjust speed, power, and the aircraft controls to keep the airplane flying safely. The next time you're sitting on an airplane waiting for takeoff, you'll know that every part of the flight, from the moment the wheels leave the runway until the aircraft lands, is made possible by the laws of physics working together all simultaneously. What may seem completely impossible is one of humanity's greatest achievements in engineering, allowing millions of people to safely travel the world every single day. Thank you.